So let's review how to graph lines. So notice everything is already in a nice useful form. I have everything in slope-intercept form. There's some exceptions down here we'll get to. But as soon as my function is in slope-intercept form, graphing is pretty easy. We know in this case the slope is -3/2 and the y-intercept is 0, 3. And so this gives us a location to start. We're going to start at 0, 3. And to move to another solution point, the slope is telling you to move down 3 and over 2, down 3 and over 2. Of course, we could also move up 3 and back 2. So in the span of very few seconds, I was able to generate 4 solution points, right? One was given, and then I found 3 others just by doing what the slope told me to do in terms of movement. So again, this graph, this is a picture of all the solutions to this function. Every single x and y value basically satisfies that equation. That's what graphing was all about. For the next one, our slope is -1/4, and our y-intercept is 0, -2. So that's basically telling us to start at 0, -2, and then the slope says to move down 1 and then over 4. Down 1 and over 4. Or we could go up 1 and back 4, right? Up 1 and back 4, but I think that's enough. And so there's basically our graph of that function, right? Of course, we could start labeling some nice clear points. So here's a picture of all the solutions to that function. And the next one, our slope is 4/3. Our y-intercept is at 0, -3. So I'll start at the point 0, -3, and then the slope tells me to move up 4 and over 3. Up 1, 2, 3, 4, and over 3. Or we can go down 4 and the back 3. Okay, so nice and easy graphing lines when we have this nice slope-intercept form. So what about these 3 on the bottom? Well, the first one looks a little different. What's changed is we have a function called d, and it actually depends on r. But when you look at that, right, it pretty much fits. We just kind of replaced some of our variables. Good old y equals mx plus b. So r being the independent variable is on the horizontal axis, and d being the function name will be the d-axis. And this is basically telling us for this situation we have a slope of 1/2 and we have a y-intercept of 0, 1. So we do exactly what we did up here. So we'll start at 0, 1, and then the slope's telling me to go up 1 and over 2, up 1 and over 2. We're going to go down 1 and back 2. And so there would be a graph of what the function d of r looks like given the form. So this is just a sneaky slope-intercept form, just in other variables, and we'll have to get used to that. Again, the function, this name allows us to talk about something. So maybe we're talking about like maybe the diameter, right? My diameter depends on the radius in some way, or maybe my demand depends on some unit price in some way. So whatever the case might be, there's a lot of different ways that we can mess around with that. The next one, f of x equals to 3. And you'll notice that even though my function depends on x, there is no x in the formula. So back in the old days, right, this is like saying y is equal to 3. And so if we look at ordered pairs that solve this, x can be whatever I want it to be. So how about I let it be -2, 0, and 2. But in order to satisfy that equation, y consistently has to be 3. So it doesn't matter what my input is, any value of x creates an output of 3. And so when I go graph this, what we end up with is a horizontal line. And if you guys recall from our review of chapter 3, when y is equal to a number, or in this case since we're using function notation, when f of x is equal to some constant number, then you basically have a horizontal line. So if I had, let's say g of x was equal to -2, that means I would have a horizontal line, right, where y is equal to -2, right? So horizontal line function. Now the last one is interesting because it's the input that's actually constant. So again, looking at a table of values, x consistently has to be 2, and then y can be whatever I want it to be. So that's how we solve that equation. X is fixed at 2. And when I go graph these solution points, right, we end up with a vertical line. So x equals to a number will create a vertical line. Of course, this is not functional, so you'll notice we're not using function notation at all. All right. By the way, over here too, you could also say that the slope is 0, and here the slope is undefined because there's no horizontal movement, so we have a division by 0. So hopefully that's a good review of our lines. More to do with lines coming up.